Hi, it's me, and I'm coming to you live for, not live, this would be a video. Tends to be that videos can't really be live because they, well, unless they're streamed. But anyway, I think I digress on that. Well, you get the point. Here we are, again, to learn more about some chemistry with me, Mr. Knight, and without further ado, here we go. Knight Chemistry, Gas Laws, Day 0. Now, Day 0. Why is it Day 0? Why do you... Let's see, Day 0. Why is it Day 0? Well, I'm glad you asked, because Day 0, it's kind of a launch point day. I'm going to kind of indicate some things to you. I'm going to kind of get you on the right path. And mainly this is going to start off with more of an intro and a self-exploration type of thing. So that's where we're going to start with it. And that's why it's Day 0. Day 1 will obviously follow Day 0 because that's how numbers go when you count. But anyway, I digress again. Once again, this is gas laws. And no, it's not the laws or the rules governing, you know, when you can release your flatulence, when you can release your gases. No, it's not about poots or anything like that. It's not about that subject. In fact, no, it's about gases and how those particles that you can't see, of course, are moving around at a random, rapid pace, demonstrating kinetic molecular theory, and of course, they're semi-random, Brownian motion, perhaps, and those gases, how those particles behave, and how their particulate behavior leads to a group behavior of the entire gas that we can manipulate and predict the outcome, and also some various different things come to light, laws and things of that nature. Things worth observing, more or less, come to light when we talk about and we think of gases in a more specific sense in gas laws. Anyway, lots of different scientists going on in this, lots of different named folks, and we're going to dive right into those. But first we've got to lay some groundwork, and that's what the beginning notes are all about. So we'll get right to it. The first thing I would hand out to you is this gas laws inquiry directions, because ideally what I'd have you do is go and explore some of these topics on your own, and then we'd be able to break them down. We'd have like more of a facilitated discussion from there, which is fun, which is a good place to be. Anyway, so what you'll do is you'll go to a web browser, and this I would hand out through a handout. I got it right here too. I'm going to cut it in half sheets. Nevertheless, I'd hand that sucker out to you and get you going on it. Bottom line is it's a lot of guys' names who came up with laws, and then there's some formulas that we have to use, which just is basically pick out the problem, pick out the unit or the number from the problem, plug them in, plug and chug, you might say. Plug and chug. Anyway, so I have a little Google Classroom tab here where you can find it on Google Classwork tab, Gas Laws, Intro Instructions. I have this document updated. The one I hand out at the point I'm recording this is an older one because I'd already made the copies. That's my own fault. Anyway, you're going to start with kinetic molecular theory of gases. You're going to work your way through each document linked, one at a time, considering some of the questions posed. You're going to read the questions, consider them, do some research on it, and then you'll know that you'll find out that the solutions are at the bottom of each worksheet, or each document there, so you'll actually be able to verify some things. You'll be able to check on yourself and kind of get the make sure answer. But I do want you to explore these topics on your own first. You're going to take good, concise notes, and then if you take good enough notes to be able to answer quiz-style questions, you know, something that you could that would be helpful for you, either to study with or to use, then perhaps in the near future, you know, you're able to use those. Then I won't make anything specific to be needed, like for a grade. So basically, just use your time wisely. Of course, I include a warning for the goofing around and such. Nevertheless, step 6 for each of the gas laws below are some important factors to consider. For each of the gas laws, comma should be, below are some important factors to consider. STP, temperature, pressure, gas constant, Dalton's law, partial pressures, Boyle's law, Charles' law, ideal gas law, and Gay-Lussac's law. There you already see these laws coming into fruition. You see them pop up right there instantly. Here we are, we're learning about it. Now, the biggest thing that I would point out next is to look at each of the formulas take a nice gander at those formulas. Really make sure you understand what you're doing with it. I don't know why this is moving so much. Oh, I see, because I was on control. If you just take a look at some of those formulas, and especially pay attention to the units. Units of pressure, units of temperature. Why would temperature in Kelvin be bolded? 273, that's interesting. That must be equal to 0 degrees Celsius. It is. I'm glad you noticed that. So, you know, that's just right there. That'll make you look at the units and just notice that those are their equivalences in the pressure units and given there. And then there's some interesting units there. There's the gas constant. There are two different R values for that, two different values for that gas constant. And which one do you use? How do you know which one? I think it probably has something to do with those units, of course. You got one is in atmosphere liters per mole Kelvin. The other one's in kilopascals liter per mole Kelvin. Yeah, that's kPa. That's kilopascals. kPa, kilopascals. ATM, atmosphere, kilopascals. Let me just start back over with that. Yeah. Anyway, degrees Celsius, Kelvin. I don't know if y'all can see this. Yeah, degrees Celsius, Kelvin. Atmospheres, kilopascals, torr, millimeters of mercury. And of course you can see how they're melded in there in the constant as well. So don't be afraid of those. Just you know, just say them back to yourself if you need to, or rewind this and go say them with me as I underline them. But those are the big units that we're going to pay attention to. Did I say torr and millimeters of mercury? I don't know if I did. Anyway, there it is. Torr, millimeters of mercury, just for you. So I'd have you just go through and read some things on kinetic molecular theory of gases, take some notes there, and then we're kind of going to dive right in. I'm going to interrupt you at some point. In a certain course, I would interrupt you sooner. If being that we're in the typical chemistry course, I'm going to interrupt you for a little bit of time, or I'll interrupt you sooner than the other course. Anyway, that is that's where we're going. That's what we're doing, and you should go do it right now. Go look on Google Classroom. Let's see if I can get there. Here we are on Google Classroom at this point. And in Google Classroom, it's not highlighted because this was actually scheduled to release in a few minutes. There's the shortcut. There's the links. It'll take you to my school website my website through the school from way back when. And you begin with kinetic molecular theory of gases. Talk about, read this question to yourself. Know that the solutions are at the bottom, so this isn't some mystery, but I do want you to research and see what Google has to say. See what some of the things you can find on Google would have to say about this. Anyway, dive into that a little bit, and you know, hopefully it'll be a good little revealing tool. There's only 4 things to discuss there. Of course, you can always get the known answer just to be certain, as it is provided for you already. And then go back, of course, and go through Dalton's law problems, Boyle's law, Charles' law, combo law, and ideal gas law. And of course, those are all going to leverage off of the idea that these law situations, these law formulas. So you're going to want to refer to those formulas while you're doing it. So without further ado, get straight to it. Pause this video right now and go take a look at that. Go spend about put yourself on a timer. Spend about 10 great minutes, or 15 if you're distracted or you feel a little fuzzy. Just do it. 15 minutes. Take some good notes. Follow the instructions of this document, which is also the one I just revealed to you. So take a look. Go. Pause. If you haven't already, do it now. And we're back. If you didn't pause, I gave you some time with the little title slide there. So go ahead and pause it if you didn't already. But if you have already, then I'm going to work you to the next part, which is still a thing that's going to lead you to on your own. But here's where we'll go. We'll go start back again at Google Classroom, where we are right now. So in Google Classroom, of course. And in Google Classroom, you will see under Resources, of course, Class Docs folder. we'll go to that class docs folder just like we know how to do. And we're in the unit gas law, so we're going to start with the gas laws unit. And then there they are, one item to choose from. The gas laws slides. Isn't that neat? And we're going to pick up on these gas law slides. You're going to want to walk through them as I walk through them in class. And mainly through the foldable section, which gets us till slide. Let's see what slide on the back of the slide there. We have to slide 30 is what it ends up being. It might be slide 29. Just depends on if I leave this essential question slide in there. No, it's kind of an old one. I have an updated one on our slides that we're going to use in class. So be prepared for that. That's actually what I'm going to refer to as I'm teaching you here on this video. So good luck. Oh, that wasn't a good luck as in like to pause or anything. That was a good luck as in like good luck as to what's to come. I think you get it. Maybe you don't, but either way, we're about to dive into the slides, so sit tight. And gas laws is where we'll begin, of course. I have the modified slide, what are the gas laws to obtain, excuse me, that's kind of our essential question, obtain, evaluate, communicate information, kinetic, molecular theory, to model atomic, molecular motion, chemical, physical process, develop and use models to quantitative, conceptually, and graphically represent the relationship between pressure, volume, temperature, and the number of moles of gases. That all really just boils down to we're going to use formulas to calculate how affecting one part affects the other. So that dives us right in, and then I'm going to have you actually go on your own. You could take a look at that slide, pause if you'd like. And then I will have you make this foldable, and then try to fill it in using the slides provided and this information. So get straight to it, fill that foldable out. That's going to be on your own. And of course, I got to fix the text there. But that's that. Good work. That's Gas Law 0. You have enough to get started today. You can get this day under your belt, even if you're at home. Go Dogs. I love it. Gas Laws.